Hello, everybody. Thank you all for joining and taking some time out of your day to explore Active Directory with me and play around with Empire in a nice little range that we provisioned for you in AWS. There's quite a lot of you. I would like to ask if you have any questions. You could use the Q&A window in Zoom, or you could use the Discord channel of the Stance Offensive Operations, which is going to be shared in the Slack chat, the Zoom chat in just a few moments. I can't promise that I will always interactively answer all your questions immediately, right? I might be talking about something, but I do promise during your lab times that I will take a look at any questions and that I will address them on an appropriate time. So with that said, thank you again for joining. My name is Jean-François Maes, which is absolutely terrible. If you are an English speaker, a lot of people butcher it. I've been called many names. Jean-François Maes is probably the worst one. So I try to basically just say, call me John. It's probably the easiest, right? I was announced, I do teach and offer the 565 course, which is a red teaming course over at SANS. And basically, to be very honest with all of you, this workshop was created on request of some of my students because they wanted to play around with the Active Directory environment after the class ends. So typically speaking, when you join a SANS course, you can choose to do it online, you can choose to do it live. You'll have access to workbooks and you'll have access to a lab environment. But unfortunately, after the course ends, the access to the lab environment also expires. So if you want to test out some of the cool techniques that you see during the course, it's kind of inconvenient if you don't have a lab environment anymore. As a result, we obviously tried to figure something out, and that's basically how this lab came to life. So I took it upon myself to do some infrastructure as a code magic, right? Some Ansible, some Terraform behind the scenes to create a relatively cheap, I would say, and fast deployment in AWS of a bare minimum Active Directory environment. Now, if you're not familiar with what exactly Active Directory is, that's great because we're actually going to be covering that here today as well. This workshop is primarily designed for absolute beginners, right? Pen testers that are still somewhat new to the industry, that might not be as familiar with Active Directory, and that just want to play around with an Active Directory environment in a safe space and practice some of the more common Active Directory attacks that a lot of red teamers and pen testers, for that matter, like to use in their toolkit. So with that being said, right, we do have quite a packed workshop ahead of us. We have about, I would say, 4 labs. One lab is going to be very straightforward. It's literally just environment setup, but it's obviously going to be the most important one, right? If you don't have the tools to play along inside of this particular workshop, then you're basically just stuck listening to me yapping about Kerberos, about Active Directory, and seeing me perform some attacks live, right? But if you want to have a good experience, if you want to maximize this workshop, it is a workshop, right? You do want to get some hands-on keyboard experience as well. So with that said, right, we're going to immediately, right off the bat, jump into lab 1, which is environment setup and spinning up the infrastructure. Now, for this particular lab, we do have a workbook available, which is actually hosted on logout.gitbook.io. Right? So that link is actually posted in the Zoom chat as well. And specifically, I want to point your attention to installing the environment. AWS is definitely very important. You do need an AWS account for this to work. And then you also need to, set up your environment in a way that you have all the tools at your disposal. Specifically, what does this mean? You will need to install Terraform. You will need to install Empire. Now, in order for you to be as comfortable as possible, I created a little script that automates it for you, but I also written some very easy to follow instructions on how to install things. Some of it is super basic, right? Installing Ansible is extremely basic if you have a Debian-based virtual machine. It's literally just apt install Ansible. That's literally it. Terraform requires a little bit more work, not that much though. And Empire also requires slightly more work, but in general, it doesn't take too long for this lab to be successful. I would say it takes you about 5 minutes to actually provision everything. So we will be using a Git repository that I created called AWS Mini AD. So you'll have to clone that into your virtual machine. You'll have to CD into the environment and then use the Python script for you to deploy the range. So if I would jump over to my virtual machine, I'm using a Ubuntu for this particular demonstration, which is also the recommended virtual machine for this workshop. Basically, I already cloned the mini AD repository, right? So I would go into the prod folder, into the files folder, and inside of that files folder, you will have the manager.py script. So if you, manager, apparently I made a typo. So manager.py is actually the script that is going to deploy the workshop for you. So basically what we need to do here is we type Python 3 manager.py or manager.py deploy -r, which is the region. Now there are a few regions that are supported. We have US West 1, US East 1, and EU West 1. So depending on whether or not you are joining us from the United States or from Europe, I would recommend you to either deploy using EU West 1 or any of the US regions. So EU West would be the one for me. The tag would be version v0.1, and that will provision your environment for you. Now, I've already done this, right? So once the environment is deployed, you will have a new file in your directory as well called student.openvpn or OVPN. Now, you will have to connect to this OpenVPN because this is going to automatically redirect you to the environment in AWS. So this is basically serving as your entry point into the lab environment that is going to get deployed for you out of the box. Now, there is one thing to take into account. If you have not configured AWS in your environment yet, you will have to perform a specific command called AWS configure. You type AWS configure in your terminal, it's going to ask you for a secret key and a account ID, which is actually going to be shown to you if you follow my instructions when you are setting up your AWS account. So eventually, at the end of the lab instructions, you'll see that we have a access key and a secret access key. Those will be the values that are going to be requested to you by the AWS console. So I will give you a few moments to actually finish up this lab, right? So lab 1, the environment orientation and spinning up, which obviously also has a dependency of installing the environment. So once again, if you don't have an AWS account yet, feel free to register for one now, as that is going to be a requirement. Other than that, you can just install Terraform, Ansible, and Empire pretty straightforwardly. Doesn't take that much time, and deploy the range. And again, the range doesn't take too long to deploy. It's all snapshotted for you. So in about, I would say, 5 minutes or so, the entire environment is going to be deployed. So you can work on this while I am lecturing, because again, we will have a lecture first before we actually dive into the first actual lab of the day. So if you can't finish lab 1 in time, right, you can of course continue to work on that while I am lecturing the rest of the workshop. Now again, if things are moving too fast for you, don't worry, all of this is being recorded, right? So you will be able to watch this again whenever you want, basically. So make sure to just follow along at your own pace, and you can simply rewatch this recording if something is unclear. So with that said, I will give you about, I would say, 5 minutes or so to actually finish this off before I actually kick it off with the lecture part of the house. And then after my lecture, we will be hitting the ground running with spinning up Empire, creating a listener, deploying an agent in the environment, and all that good stuff. So I'll set up a little lab timer here for, I would say, 5 minutes to actually give you the time you need to provision everything to deploy the lab. and the lab is going to be ready for you once we hit lab 2, which is the Empire setup. So I'll start a little timer here. I'll go off screen for about 5 minutes or so, and then we will hit the ground running. Of course, again, if you have any questions, feel free to use that Zoom Q&A chat or use the Discord channel as well. I'm trying to keep an eye on both. We'll be kicking off the lecture in about 8 seconds or so. So again, feel free to keep working on deploying the lab, right? So it's all nice and ready for you to go once we actually hit the first lab of the day. Well, technically the second lab of the day. So with that said, right, the first thing that we have to talk about is, of course, what exactly Active Directory is, why we should care, and also introduce our C2 framework of choice for this workshop, which is going to be Empire. And it also is actually a great pleasure to say that that some of the authors or devs of Empire are currently following along with the workshop as well. So a huge shout out to them because they do excellent work. I really love the framework. It's also one of the frameworks we use in the course itself as well. But I'll get to that in a minute. Let's first talk about Active Directory. So what exactly is Active Directory and why should we care about Active Directory in the first place when it comes to offensive security? Well, as it turns out, most organizations out there are leveraging Active Directory in some way, shape, or form. Now, traditionally speaking, right, environments have been using Active Directory on-prem, right? So literally hosted on servers that they own, right? Enrolling computers to the domain on-prem, and everything was just used to centrally manage instances, computers, servers through GPOs, so group policy objects. We'll talk about that as well. And it was basically to facilitate IT management, right? So in order for us to simply configure a fleet of computers or servers without us having to go from one computer to another computer, typing in all kinds of commands, we simply create a domain, we join computers or servers into that particular domain, and we can then use a centralized server, also known as a domain controller, to actually control all the nodes inside of the domain, right? So it was literally designed to make the life of administrators significantly easier. Microsoft themselves describe Active Directory as enabling centralized, quote unquote, secure management of an entire network, which might span a building, a city, or multiple locations throughout the world. Nowadays, Active Directory is still very much in use on-prem, but also in the cloud, right? Over time, there was a large migration, a large adoption of people leveraging the cloud. And of course, Microsoft couldn't fall behind in the cloud race. So they created Azure Active Directory. And nowadays it's renamed to Entra ID. Microsoft really likes renaming things. I think just recently, they even renamed Office 365 to something else as well. So at some point in time, you actually need a PhD in Microsoft naming convention to understand or to know what they are talking about. So that being said, right, why do we actually care about Active Directory in the first place? Well, as it turns out, it's used by a lot of organizations. According to Microsoft statistics themselves, about 90 to 95% of the Fortune 1000 companies are using Active Directory, so on-prem, or Azure Active Directory, or a combination of both. I think we have about 260 people joining us live. If I would ask you all to raise your hand, I know you can't, right? Because it's virtual. How many of you are using Office 365? I guarantee you that about 200 of you, or maybe even more, would basically raise your hand saying, yeah, I would use Office 365. Well, guess what? That means that somewhere in the backend, your organization is very likely using some cloud-based Active Directory resources as well. Now, it's not just about the Azure, not about the Fortune 1000 companies, right? It's also about the small and medium enterprises. They also prefer leveraging Active Directory as it does reduce technical overhead. It simply is a facilitator and an enabler. It's also free of charge, more or less. But my particular opinion in why Active Directory is as popular as it is because it's simply, well, there's not really that many alternatives out there. If you are using Windows in a enterprise setting, there's not that much else that you could use to centrally manage your environment. Active Directory in general was invented by Microsoft. Windows was invented by Microsoft. Kind of makes sense to use Active Directory from the same developers as the actual developers that used or that created your operating system. So that is why Active Directory is, of course, also very, very useful from a security perspective. If you understand the concepts and the different components in Active Directory, you can actually figure out that there are some attacks, by now pretty well-known attacks for that matter, that can be executed that simply work. This is not like an exploit or anything like that. It's not a inherent vulnerability per se, although I will admit some of the attack paths that we are going to see today are somewhat borderline exploitation, but not really though. It's literally just using the intended functionality of Active Directory to perform specific attacks on the environment that can allow an attacker to elevate their privileges in the environment as well. So Active Directory, as I said, it enables or facilitates management from a centralized location. And you can actually compare Active Directory with a database. Quite literally, an Active Directory environment can be compared to a database. So anything that you would expect a database server to have will be present in Active Directory as well. For example, if we are going to add a user into our database, right, kind of makes sense that a user is going to have some specific attributes, right? A human being typically has a first name, typically has a last name, maybe has a physical address, a phone number, an email address, maybe even favorite beverage. Yes, that is actually a property in Active Directory as well. But if you would like to add a computer object in the Active Directory environment, so if you want to add a computer to your database, well, a computer doesn't really have a first name, doesn't really have a last name, doesn't really have a physical address. Well, maybe a rack in a data center, right? But not an actual physical address. So what does a computer have? Well, a computer might have an operating system, might have a IP address, might even have multiple IP addresses, a DNS host name, right? So those would be properties that we can assign to a computer. So as you can already imagine, right, Active Directory needs some kind of schematic, some type of blueprint to basically understand what you are trying to add to the environment, right? For example, if you try to add a computer object, Active Directory will have to know, okay, a computer object has an IP address. If you want to add a human, right, a user in Active Directory, well, the Active Directory environment needs to know, oh yeah, it's a human. A human doesn't have an IP address, but has a first name. So in Active Directory, we have this blueprint that we typically refer to as a schema or a scheme, right? It's the blueprint, it's the design that basically tells you which properties can be attributed to which object in Active Directory. Now, I stated that Fortune 1000 companies are using Active Directory. Now, as you can imagine, Fortune 1000 companies are rather large, right? They have a lot of resources, a lot of employees, a lot of computers, a lot of servers. So in some extreme instances, an Active Directory environment can become extremely large. And when I say extremely large, I'm talking about hundreds of thousands, if not millions of records inside of the database. Well, if you want to retrieve the information of, I don't know, Bob the Builder, right, in your Active Directory environment, if Bob the Builder would be an employee of your organization, and your database has 1 million records, well, it's going to take you quite a bit of time if you would have to search the database manually, right? If you would literally have to scroll through 1 million records without any type of filtering mechanisms, any type of sorting mechanisms, that could take quite a bit of time. So obviously in the backend, right, the Microsoft engineers did do proper research and obviously created performance algorithms, so it's easier for us to actually query Active Directory. That means that we have things like indexing, that we have things like querying, we have specific tools that we could use to query Active Directory, ranging from programmatic tools like PowerShell scripts to graphical user interfaces, like, for example, the remote server administration tools, also abbreviated as RSAT, and a variety of other things as well. Now, typically speaking, if we have an Active Directory, we have a centralized control server, right? That's literally why we created Active Directory in the first place, because we want to centrally manage environment. If we want to centrally manage our environment, we need that database server. And in the context of a Active Directory environment, the database server is what we call the domain controller, right? So the domain controller is going to be the server in our environment that contains all the records of all the resources inside of that environment. Now, if you've ever managed computers before or servers before, you very likely understand that just having one database server is kind of a recipe of disaster, right? A single point of failure is never a good idea in a network architecture. So that's the same in Active Directory. It's probably not going to be a very good idea to just have one domain controller. Something would ever happen to that domain controller. For example, I don't know, it loses internet connectivity, or the server that is hosting the domain controller loses power for some reason. Well, that would mean that basically your entire environment would now no longer be able to authenticate. And that would lead to massive business impact. So typically environments will have duplications, right? They will have multiple domain controllers in the environment. So if one goes down, the other one can be switched over to, right? Now, since we're talking about data and databases, it makes sense if we have multiple database servers that these database servers have to remain in sync with each other, right? They will have to have a way that they can communicate changes to the database. Because let's say that that doesn't happen, right? That a database is not syncing changes from one database server to another database server. And let's say that we are trying to check our bank account, right? So we go to an ATM, we put our bank cards into our ATM, we check our balance. Let's say, for argument's sake, that we have $1,000 on our bank account. Okay, great, we have $1,000. Let's try to wire some money from our bank account to another bank account, right? So we submit a payment, we try to transfer $100 from our bank account to someone else, and now our balance would be $900. Now, if we would take our bank card back out of the ATM, we put it back into the ATM, and now the ATM would get their data from another database server. Well, guess what? Your bank account would now say, hey, you still have $1,000 on your bank account. So obviously, that would be not great from a banking perspective, right? So obviously, database servers need to remain in sync, and they actually need to do that rather fast, right? If something changes, then they need to replicate that change pretty much instantly to the other database servers in the environment as well. So if we apply that to Active Directory, domain controllers need a way to replicate changes with each other as well. Microsoft actually created a replication protocol, which is a very interesting protocol to attack, as we are going to be seeing later on in this workshop. So hopefully that kind of gives you a little bit of context of exactly what an Active Directory environment is. In essence, TLDR, it's a giant database. Now, there is also the concept of trees and forests in Active Directory as well. And this is a core concept to understand from an offensive security perspective. Because from a red team engagement and even from a pen testing engagement, it's quite common that we will have to achieve objectives in a particular remote domain. Let's say that we got initial access through, in this case, let me get a little pointer going here. Let's see. laser pointer. All right. So let's say that we have this def.draconum.corp domain, right? Let's say that we social engineered someone in the def.draconum.corp domain and we got initial access. Awesome. But let's say that our red team objective is inside of thunderbird.corp. Well, that would mean that we somehow would need to navigate from dev.draconum.corp to thunderbird.corp. And luckily for us, that can actually be achieved if there are domain trusts. So what exactly is a tree? What exactly is a forest? And what exactly is a domain trust? Well, as it turns out, organizations can have multiple domains. This could be done for logical separation, for example. Let's say in our case that we have this company, a fictional company called Draconum.corp. And let's say that they have a software product and that they interact with Active Directory on a regular basis. And let's say that they have developers that are testing this software. Well, they might want to isolate that particular test from the day-to-day business operations. So they could have a dev environment that is completely isolated from the main business architecture. So in this case, we would have a tree, right? A Draconum tree, which contains two domains. These two domains would be draconum.corp, which is the main domain, right? That's the root domain. That's the tree root of the Draconum tree. And we have a child domain, which is called dev.draconum.corp. Now, how do we know if a relationship between a domain is a parent-child domain or a parent-child relationship? Well, pretty straightforward. A parent-child relationship will have a very easy to spot indicator. The child domain will carry the root domain's name inside of the child's domain's name. So in this case, the child is dev.draconum.corp. So draconum.corp is the name of the parent domain, right? So the root domain. If you have a collection of domains that are related to each other, we are talking about a specific tree. So in this case, we have a Draconum tree. This Draconum tree has two domains inside of it. We have the Draconum.corp domain, and we have the dev.draconum. Now, in this case, what actually happens is Draconum is doing quite well for themselves. And Draconum is doing so well for themselves that they eventually decide to acquire another company. Now, this company already has its own Active Directory environment as well, which is quite common. Remember, about 90 to 95% of the Fortune 1000 companies have Active Directory, and small to medium enterprises also typically leverage Active Directory as well. So it's not uncommon if you would merge or acquire another organization that they will have their own Active Directory environment as well. Now, there are two things that we could basically do in this scenario. Either when we acquire, in this case, Thunderbird.corp, we could say we are going to decommission the infrastructure of Thunderbird.corp, and we are going to basically migrate everybody from Thunderbird.corp into our Draconum.corp domain. Now, this is a valid use case. You could do this, but it's going to also be one that is quite technically complex, right? Because you very likely have a large migration on your hands. On the other hand, what we could do is we could say, hey, we are simply going to create a link between our infrastructure and the existing infrastructure of the company that we are purchasing. We are going to start establishing a trust between our infrastructure, basically stating, hey, our infrastructure trusts this new company's infrastructure. And this means that now people or resources from Thunderbird.corp would be able to access resources from Draconum.corp and vice versa. Does that make sense? Right. So again, a trust is basically just allowing resources from one domain to access resources from another domain. That's basically what a trust is. Now, when it comes to administration, every single domain has God mode users. right? People that have full admin powers in the environment. And this particular group of users is called the domain admin group. Now we also have gods amongst the gods, right? And those would be the enterprise admin group. Now the enterprise admin group basically has admin rights on every single domain in a specific tree. So in this case, we would have an enterprise admin group in Draconum.corp, which has domain admin privileges on Draconum.corp and dev.draconum.corp. And we would have the Thunderbird.corp tree, which would also have an enterprise admin group and a domain admin group. But in this case, they would basically be the same because Thunderbird doesn't have any relatives, right? They don't have any children. So this is a standalone tree. The tree only has one domain, which is the Thunderbird.corp domain. Now, once a trust is set up between a domain, that means that authentication is flowing, right? So if we have a trust between two domains, that means that resources from one domain can access resources on the other domain. That being said, right, unfortunately, authorization rather, still needs to be arranged, right? So we still need to add people to the appropriate groups so they actually have access to the resources that they would have access to. For example, they might need write privileges on a file share or read privileges on a file share. So we'd have to add those people into our local groups. All right, so that in a nutshell is Active Directory. Right, so Active Directory facilitates management. We basically group computers and servers into a cluster, and we can start centrally manage them on a domain controller. Okay, great. So what about the offensive side of the house, right? Well, if you've ever done a pen test before, or you've done a red team before, you very likely are aware of the concept of a reverse shell. Even if you're a blue teamer, you very likely have heard of the concept of a reverse shell before. Basically, a reverse shell is going to be a port that is open on an attacker-controlled infrastructure, typically hosted on the internet, that is basically going to listen for an incoming connection. Now, we are going to create a payload, right? Some malware, a implant, for example, that we are going to send into the environment in some way. That could be either through social engineering or through exploitation. If our malware gets executed, it's basically going to send a shell, so a CMD or a PowerShell prompt, over the internet to our attacker-controlled infrastructure, allowing an adversary to execute commands on your computer. Now, unfortunately, from an offensive perspective, a reverse shell is great, don't get me wrong, but it doesn't really scale well, right? If you need one reverse shell, that's fine, right? You can easily manage one reverse shell. But if you need 10 reverse shells or 100 reverse shells or 200 reverse shells, well, things are starting to get really messy with terminal windows because basically every terminal window would be a reverse shell. So if you need 200 reverse shells, you would now have 200 terminal windows. So it doesn't really scale very well. And also from an exploitation perspective, the only thing that you can do is literally execute either shell commands if you have cmd.exe capabilities or PowerShell scripts at most if you have a PowerShell connection back to your attacker-controlled infrastructure. Unfortunately, from an offensive perspective, that simply doesn't cut it in today's day and age, right? We typically want to have more sophisticated capabilities. We, for example, might want to be able to create a screenshot, or we might want to start a keylogger, or we might want to upload or download files, or we might want to execute scripts in memory without having to drop them to disk, right? Or we might not even want to execute any shell commands or any PowerShell commands. You might want to live completely in memory and just leverage the Win32 API using things like beacon object files, for example, and completely remain in memory without spawning any additional processes. Now, a reverse shell is simply not going to cut it, and that's why we have what we like to call command and control. A command and control server, or a C2 server, consists of a few things. It consists of a server component, right? So once again, attacker-controlled infrastructure, typically exposed on the internet, and a client, which is our implant, our malware, right? Or little payloads that we have to deploy on the target system somehow. Now, once that implant gets deployed successfully, we would have a reverse connection back to us. But now it would not be a reverse shell, right? It would instead be an implant that is calling back to us. Now, an implant can have many different names. In Empire, an implant is called an agent. In Cobalt Strike, an agent or an implant is called a beacon. In Covenant, it's called a grunt. In Havoc, it's called a demon. In Metasploit, it's a interpreter shell, right? So there's a variety of naming conventions out there, but the generic naming convention would be a implant. So when it comes to infrastructure, very straightforward. We have our server component. Our server component will have to deploy some type of listener, right? It needs to open a port and listen for incoming connections. This typically originates using HTTP or HTTPS or DNS because we typically communicate over the internet. And we also need a client, which is our implant, which very likely needs to become proxy aware because in the vast majority of the cases, there will be a corporate proxy in the environment that is going to basically monitor and secure network connections from their employees. If our implant isn't proxy aware, it would try to communicate directly over the internet to us, and we wouldn't be able to catch that connection because it would be dropped by the corporate firewall. So one piece of advice that I can give you if you want to use a command and control server for red team operations or even for pen testing perspective, I highly recommend you to use one that has proxy awareness built in. Now, when it comes to listeners, right, a command and control has a listener. Listener is a port that we open on the internet. Now, this in itself isn't necessarily OPSEC safe. In SEC 565, we cover OPSEC. We teach you how to obviously create infrastructure in a secure way. Unfortunately, due to timing constraints, we can't really get into it right now from a workshop perspective. But if you're interested in learning more about that, well, you might be interested in taking a course. That being said, a C2 implant needs to have a listener. So we first need to deploy our server on our attacker-controlled infrastructure, start a listener to listen for incoming connections. And once we have a listener established, we can start creating a payload. Now, when it comes to communication channels, typically, again, our C2 is hosted on the internet, right? So our most popular C2 communications is going to be HTTP and HTTPS, but also DNS. And typically, we also have some type of peer-to-peer communication in case we want to laterally move to air-gapped networks, which basically means the computer that we want to access doesn't have direct internet connectivity. Then we might want to establish communications through, for example, SMB, mail slots, or TCP, or even sometimes UDP traffic as well. And there are some examples of leveraging trusted software as a custom command and control channel, things like Gmail, for example, Slack, Twitter, or X, or whatever Elon Musk wants to name, the technology, and other things as well. Quite notably, a few years ago, a Russian threat group used Britney Spears' Instagram. Yes, you heard me correctly. Britney Spears' Instagram as a command and control channel as well. So basically, the world is your oyster, right? Anything that has an API that allows you to send and receive data could technically be used as a command and control channel. Bringing us to Empire. Empire has an interesting history attached to it. Empire used to be called PowerShell Empire and essentially used to be a proof of concept to convince Microsoft that Empire wasn't very secure. Eventually, Microsoft caved and obviously improved PowerShell with security measures like AMSI, for example. Eventually, PowerShell Empire died, right? Development stopped until at some point in time, our dear friends over at BC Security picked up development again, gave the project new life, renamed it to Empire. It definitely still has PowerShell roots, but it is not just PowerShell anymore, has implants now on Nim, Iron Python, and a variety of other languages as well. So from a quick start perspective, right, very simple. You start PS Empire in the console after installation. You wait until the web server shows up. It's going to show you in the output of your console. You start your web browser, go to the web console, type in your credentials. Once you log on to the Empire console, you create a listener. After you create your listener, you create an implant. And after you create your implant, you have to somehow get it in the environment. And obviously, that is the hardest part, but that's also the part we can't really demonstrate here, right? We're not going to do any live social engineering or anything like that. So we're kind of skipping this step. We're going for an assumed breach scenario where we're basically going to RDP in the environment ourselves and deploy our agent. All right, that brings us to our lab, right? Lab 2, initial Empire setup and agent callback. So I'll jump into my VM and do this lab with all of you. So the first thing that you have to do is you need to make sure that you are connected to your student.openvpn file. So make sure that you are connected to your OpenVPN and take into account your TON0 adapter. So if you do IP address, for example, or IPA, you would actually get your TON0 adapter IP address. This is going to be important because we will have to create a listener that is listening on this particular address, right? So we are going to launch a new console, and I'm going to go into my Empire server. Sorry, it's in documents. For me, it would be an opt for you. Sudo PS Empire server asks me for my root password, which I just submitted. Now we are going to see some errors, but that's completely fine. Don't worry about those. Eventually, we will see that our application is running and that our Starkiller UI is served on our web interface. So we can copy that link, open a web browser, and go into our Starkiller. Now, you would not be logged in, so I will log myself out. And you will be basically greeted with this particular screen. It's going to ask you for a username and a password. The default username is Empire Admin, and the default password is password123. Or is it 1234? I think it's 123. Yeah, it's 123. You would be greeted with basically this screen. I'm going to delete some of these artifacts because you wouldn't have these if you have a clean Empire. So there you go. So basically on the left-hand side will be your controller menu, right? This is where you can access specific sections of your Empire C2 framework. Most important one for now is going to be your listeners tab. Now, the first thing that we'll have to do is press that orange create button and select HTTP. Now it's going to ask you for your IP address. Your IP address has to be the IP address of your TON0 adapter. In my case, that's 10.802, and that should be the case for the vast majority of you as well. It's also going to ask you for a port. Now it's going to assume port 80. You could also use HTTPS if you generate certificates. Again, we covered this in 565. We're not going to be covering this in the workshop. So you could technically use port 80. I don't like using port 80 though, because you might actually have things running on port 80. Maybe you have a web server running on port 80, for example. So I like to use port 8000 instead. But if you want to use port 80, you can. And that's basically all you need to do to get your listener created. Now you can give it a name. My name is just HTTP, but you could call this whatever you want. It could be workshop listener, it could be workshop HTTP. So you can give it a name to whatever you want. Now you have two options to create your payload. You either have this suitcase option here or the suitcase option here. For this workshop, I'm going to be using the left-hand side of the house. So I'll click on my Stagers tab right here. Again, I have this orange create button. So I'll press the create button again, and I'm going to choose the multi-launcher option. Now I need to give this launcher a name. I'll call it workshop launcher HTTP listener, for example. Now I need to tie it to my listener, which makes sense, right? Your implant needs to know where it needs to connect back to. So your implant needs to be tied to your listener. Conveniently, we have this drop down menu that we could use to tie our implant to a specific listener. And that's basically all we need to do. We press that submit button and we see a green approval, basically saying stager created. We now have these two buttons here as well that allows us to copy our payload to the clipboard. So now that we have that part down, we are going to RDP into our workstation. So I'll create a new tab and I'll RDP into our workstation, which is going to be a workstation that is going to be hosted on our sandbox domain. Meanwhile, I see some questions. Oh, I have a connection error. US West 1, yeah, that looks good. It's interesting that US West 1 didn't work for you, Jesse. Maybe try US East 1. Hopefully that works for you. Let me see here what my problem is though. Can't connect. It seems to be a VPN issue on my side. Oh yeah, indeed, unreachable. Let's see if I reconnect. Yeah, interesting. Let me check my backend here real quick and see if my instances are still running. Maybe I'll have to deploy instances myself as well, because I might have destroyed them, which would be quite ironic. But it is actually true. That's funny. Hold on, I need to deploy my own range. So -3 manager deploy region US West v0.1. Right, in the meantime, right, you can follow along with the workbook. So if you check lab 2, Empire setup and initial agents, you will have all the workbook instructions. So I'll let you loose for now while my lab is spinning up. I think I'll give you about 15 minutes, I would say, for this lab until I jump back in and do the actual demo. So I'll set up a lab timer here for 15 minutes. In the meantime, if you have any questions, feel free to reach out to me, of course. And I will be right back with a provisioned range for myself, right, where I can, of course, play around with all of you as well. So see you in about 15 minutes. And again, I'll be answering questions in the meantime. All right, so I do realize that you have about 5 minutes left, but I just got my range provisioned, so I'll be jumping in. Feel free to continue working, right? I'll just be demonstrating what I did. So first things first, right? I did my manage script. So we have Python manager, well, manager.py deploy, right? -r, we specify a region. I now deployed in US East 1 and the version tag. It's going to do all kinds of Terraform shenanigans until eventually, when we scroll all the way down after the provisioning is done, you will see that we have successfully spun up the environment. There you go. The lab is ready to use. And we have this OpenVPN file that we could use. So we do sudo openvpn student.openvpn. We see that the initialization sequence is successful. Take a look here. We see our IP address, 10802. Now we need that empire. Mine is going to be in documents, but if you installed it in using the install script, yours should be in opt. So that's a small difference between my environment and your environment. Requires sudo privileges. That's going to load up nicely until eventually Starkiller is going to be available for us. Eventually. There we go. All right. Need to RDP into the host. So let me quickly look in the workbook for the credentials because I don't know them by heart. All right. Once we have an RDP session established, we can go to our stagers. We have these three dots right here, copy to clipboard. We go back to our RDP session. My screen is too small. Okay, hold on. I need to switch this around. Wait 1 sec. Switching the lab instructions and my main screen. All right, and I'll screen share from my other screen. Cool. So now we should see screen 1, which is sufficiently large. Launch a PowerShell window. Okay, and copy paste this stager in there, press enter. And now if we go to our link icon, we will see that we have a new agent that has checked in. Now with this new agent, we can click on it and we can start executing shell commands if we wanted to, or we could use situational awareness, post-exploitation tools like, for example, seatbelt. Seatbelt is a pretty famous tool written in C# that allows you to enumerate all kinds of things. For example, interesting files. Now, ironically speaking, the only interesting file that should be showing here would be our own stager. So if we take a look at the output, if we go to our task tab, you'll see that we have a task here that's going to get executed. Eventually, there is some jitter, right? So it does take a little bit of time for the task to complete, but eventually we're going to see output here. We see that there is no interesting file. If we go back and we do seatbelts, interesting process instead, interesting processes, then we should see our PowerShell stager as an interesting process. So again, takes a bit of time for that task to complete. And eventually, indeed, we do see that interesting file right here, or interesting process right here, which coincidentally is, of course, our command that we are executing ourselves to get our agent back. So that's in a nutshell, right? How we can get our hands on a agent. That's obviously not the only thing we can do from a stager perspective. We could, for example, create an HTA. An HTA file is also pretty well known. We can give it a name here, workshop HTA, tie it to a listener, submit, there we go. And now we have created an HTA file that we could download. Now, this download is basically just going to be text, not a weaponized HTA file, but we can copy the actual content. And we can, for example, open this in terminal and create a new HTA, like payloads.hta, for example. Or we could also just rename that text file to a .hta file. So now basically what I did is I copied the payloads into a new file, call it payloads.hta. And now what I could, for example, do is I could do Python HTTP server, let's say port 6666, because the number of the beast, right? We go back to our RDP, CMD, this time not PowerShell. And we could use a living off the land binary and script, so a Microsoft signed binary that already exists on your operating system called mshta.exe. And we specify our IP address, our port, and then our payload, which is called payloads.hta. Now, if we would take a look at our Python server, we see a hit 200, which means OK. So that means that our payload got downloaded. And if we would now take a look at our agents again, we would see that we have yet another Empire agent that is calling back to us. Now, this is interesting because, of course, in some organizations, you might have things like app locker, like application control, that might be in the way of actual execution of particular payloads, right? So if we have a Microsoft signed binary, there is a good chance that the Microsoft signed binary can actually bypass any of the application control restrictions that might be put in place on the environment as well. All right, now I'm gonna have to switch screens again to screen 2. Let's take a look at the Q&A here. With dynamic resolution, you can make your RDP window bigger. Yeah, that's a good one, Matthews. Thank you for that. All right, now let's talk about Kerberos, right? Now, in Active Directory, again, right, Active Directory is the combination of multiple servers that are centralized. We have two forms of authentication. We have NTLM authentication, which falls out of scope of this particular workshop at this point in time, and we have Kerberos authentication. Now, when it comes to Kerberos authentication, right, I typically see a lot of students struggle a little bit with Kerberos, which is perfectly fine because Kerberos is a complex beast to tackle. So we have a bit of a practical example. We have a dear friend of ours called Alan Marshall, which is trying to authenticate to a file server in the Active Directory environment using Kerberos authentication. Now, Kerberos is actually a DLL that is hosted in LSAS. Right? So lsas.exe or local security authority subsystem.exe is basically one of the most important processes on a computer because that is hosting all of the security support providers, which basically are going to help us authenticate to resources. One of those security support providers is Kerberos. Now, when it comes to Kerberos, Kerberos has technically 4 supported encryption algorithms, but in reality, only 3 supported encryption algorithms, because let's face it, DES is outdated. DES hasn't been around for a variety of reasons. It's cryptographically very insecure, and therefore it's no longer being actively used in a modern environment. So unless you have a Windows Server 2000, still running around in your environment, which I hope is not the case, you typically don't have to deal with DES anymore. So that leaves us with 3 actual encryption algorithms. We have RC4 encryption, AES-128, and AES-256, with AES-128 probably being a bit of the odd one out because it's very much unused, to be honest. Either it's going to be RC4 or AES-256. It's very rarely going to be AES-128. So that being said, those are your encryption algorithms that are supported by Kerberos. So how does Kerberos authentication actually work? Well, the first thing that Alan Marshall has to do is Alan Marshall has to prove to the environment that they are in fact Alan Marshall. How does that work? Well, Alan Marshall has to do something called pre-authentication. This means that Alan Marshall is going to send a timestamp. So when Alan Marshall wants to get access to the Active Directory environment, and it's going to send that timestamp in an encrypted fashion. So either using RC4, AES-128, or 256. All of these encryption mechanisms require an encryption key. And this encryption key is going to be Alan Marshall's password. So awesome sauce 123. Now, if a domain controller receives the encrypted timestamp, the domain controller is going to check the source, in this case, Alan Marshall. Now, the domain controller is the centralized server in the environment, right? That means that the domain controller has all the records of all the users and all the computers, including their secrets, so including the passwords. So once an encrypted timestamp is received by the domain controller is simply going to check its records for a decryption key of Alan Marshall. If the domain controller successfully decrypts the timestamp of Alan Marshall gets a ticket granting ticket, also known as a TGT. Now, this basically proves to the environment that Alan Marshall is Alan Marshall. Once Alan Marshall has a ticket granting ticket, he will have to use that ticket granting ticket and exchange that for a access to the file server. In this case, that means that Alan Marshall will need to submit its TGT to the KDC. The KDC is going to check, is this a valid ticket granting ticket, yes or no? If it's valid, then Alan Marshall gets the service ticket to connect to the file server. Now, if all of this sounds very complex to you, that makes total sense, right? I would be very confused as well. In fact, I was very confused myself when I first learned about Kerberos. So if that doesn't make any sense, allow me to simplify it with an analogy. Let's say that you are an adrenaline junkie and you like visiting theme parks. So you like riding cool roller coasters. Okay, great. So let's say, hey, you want to visit a theme park, you booked your ticket, it's in the middle of the summer, you drive to the theme park, you get to the theme park. Obviously, if you want to enter the theme park, you need an entry ticket, right? There's probably some type of gate that prevents you of entering the theme park if you don't have a ticket. So you need to buy a ticket either online or at the register, use the ticket to get access to the actual theme park, right? Okay, great. You are now inside of the theme park, ready to start your day, ready to ride some cool roller coasters. But we have a problem. What is the problem? Well, the problem is it's the middle of summer. And that means that the theme park is very crowded. Now, unfortunately, we don't like standing in line. We don't want to wait 4 hours to ride a roller coaster, which is over in maybe 30 seconds. So luckily or unluckily, depending on whether you like spending money, theme parks typically are quite capitalists. That means that there's very likely going to be a way in the theme park that you can somehow skip the line. And that typically is done by, guess what, spending more money, right? So you typically need to have your entry into the theme park. And then you can probably purchase some type of fast pass, some type of skip the queue, lightning lane, Genie Plus, right? Whatever they want to call it, in Disneyland or any other theme park. But that does require you to already have an entry ticket in the theme park, right? So if we transpose this back to the realm of Kerberos, right? Your entry ticket, right? Your tickets to enter the theme park is the ticket granting ticket. So that basically just proves that you are allowed to be here. You are allowed to enter the theme park. You are allowed to enter the Active Directory environment. But if you actually want to ride a roller coaster, or in this case, in Kerberos, access a resource, then your entry ticket isn't going to be sufficient. You will need some type of other ticket, some type of skip the line ticket, which is going to be your service ticket or your ST. So hopefully that makes it a little bit easier for you to remember, right? So first things first, Alan Marshall needs to get a ticket granting ticket. Once Alan Marshall has a ticket granting ticket, they can use the ticket granting ticket to get a service ticket to access the actual resource that you are trying to access. Now, there is one very important detail that I haven't mentioned when it comes to Kerberos, and that is the fact that in Kerberos authentication, it's actually the file server, so the resource, that is going to decide whether or not Alan Marshall has access to that resource. So it means the domain controller does not care if Alan Marshall has permissions to access the file server. The only thing that the domain controller cares about is whether or not Alan Marshall has a valid entry ticket. So whether or not Alan Marshall has a valid ticket granting ticket. As long as Alan Marshall has a valid ticket granting ticket, they can use that ticket granting ticket to request service tickets to any resource in the environment, even resources that Alan Marshall doesn't have access to. Because again, it's the resource itself that is going to decide whether or not Alan Marshall has the appropriate permissions to access that resource. Now, when it comes to Kerberos authentication, there are three important encryption keys. The first encryption key is going to be called the KDC's long-term key, also known as the Key Distribution Center's long-term key. This is derived from the KRB-DGT account password, also known as the Kerberos ticket granting ticket account password. Now, the KDC's long-term key is used to encrypt the server portion of a ticket granting ticket. This is going to be very important for you to understand when we are attacking Active Directory. Now, another important key is the client's long-term key. Now, the client's long-term key is, surprise, surprise, derived from the client, in this case, Alan Marshall. So the client's long-term key is basically Alan Marshall's password. In this case, awesome sauce 123. And then we have the target long-term key, and the target long-term key is the actual target, right? So the recipient, in this case, the file server. So the target long-term key is going to be derived from the service account's password that is being hosted by the file server. So one step at a time, again, Kerberos authentication, first step, pre-authentication. Alan Marshall sends the encrypted timestamp. If the encrypted timestamp is successfully decrypted by the KDC, the Key Distribution Center, also known as the domain controller, Alan Marshall gets a ticket granting ticket. A ticket granting ticket looks a little bit like this, right? So we have a user portion and we have a server portion, which has a PAC file inside of it, a privileged attribute certificate. Now, when it comes to security information, it's actually the PAC that is relevant. The PAC is where all the sensitive information is being stored, and that is what eventually the file server is going to be using to make a decision whether or not Alan Marshall is allowed to access the file server, yes or no. So a ticket granting ticket is encrypted with the KDC's long-term key. It's actually encrypted with the KDC's long-term key twice, because the target long-term key, when it comes to a ticket granting ticket, is the domain controller. So when it comes to a ticket granting ticket, it's actually the same key, the KDC's long-term key, that is used to encrypt the pack inside of a TGT. That is why that KRB TGT account is very, very important in Active Directory. And that is why the KDC's long-term key is the most important key in AD. If you lose that key, that means that anybody would be able to start modifying security information inside of a ticket granting ticket, which is, of course, very bad. And that's obviously something that we are going to do from an attacker perspective. This brings us to a service ticket. And a service ticket is going to be the follow-up, right? So once you have a ticket granting ticket, you get a service ticket. Again, much like a ticket granting ticket, a service ticket has a client portion and a server portion. This time, the server portion is encrypted with the KDC's long-term key, once again, but also with the target long-term key, which is going to be the file server. This means that the file server will be able to decrypt the pack inside of the service ticket to inspect the pack inside of it. That includes Alan Marshall's security identifying information. And based on that information, the file server is going to make a decision whether or not Alan Marshall is in fact able to authenticate to the resource, yes or no. This brings us to Kerberoasting and DC syncing. So what is Kerberoasting? Now, Kerberoasting is a very well-known attack against Active Directory, specifically in how service tickets are being generated. Now, if you recall from my explanation, in Kerberos authentication, it's the resource that is deciding whether or not a subject has access to it, yes or no. So again, the domain controller doesn't care whether or not you are allowed to access the resource. The domain controller only cares whether or not you have a valid ticket granting ticket. So in order for you to perform a Kerberoasting attack, you need one prerequisite, and it is you need to have a valid ticket granting ticket. So that means that you need to have a session in Active Directory that is running under some type of user context, which, surprise, surprise, we now have. Right? In our workshop, in our first lab, well, technically second lab, we compromised a user and we have an agent running. This means that we could now use that user's ticket granting tickets to request service tickets for every service in Active Directory. Now, a service ticket has a server portion, which is encrypted by the target long-term key, which is the service account's password. So if a service account has a weak password, that means that we would be able to successfully brute force the server portion of the ticket. And coincidentally, service accounts are quite notorious of having weak passwords because people are afraid of changing their service account's passwords as they might break things. They might think that they would break things. So it's not uncommon, even in the most mature environments, that there are service accounts that have very weak passwords. Passwords like change me123, passwords like password123, company name123, summer123, spring123, winter123, you name it, it exists. Now, when it comes to Kerberoasting, there are some OPSEC considerations to take into account from a red team perspective. Typically speaking, you don't want to Kerberoast all service accounts because that is going to raise significant flags. In a red team environment, you want to blend in, and therefore you also want to make sure that you are behaving as a legitimate user. It's very unlikely that a normal user is going to request service tickets for all services in the Active Directory environment in a matter of seconds, right? So it's very likely that you want to do a low and slow approach, that you want to really take a look at service accounts that might interest you, and then Kerberos those service accounts instead of all service accounts all at once. Now, again, remember, Kerberos has multiple encryption algorithms, including AES-256. Now, the default encryption algorithm used in modern environments is the highest supported one. That means in most environments, that is going to be AES-256. Now, AES-256 is notoriously harder to crack than RC4. So you kind of need to make a little bit of a risk-benefit balance here. Or you're going to be performing a Kerberoasting attack by requesting service tickets using RC4 encryption and risk standing out, but having an easier time trying to crack these tickets? Or are you trying to blend in more, and are you going to request these service tickets using AES-256, but risk having to wait a significantly longer time to decrypt the actual service password? Maybe you won't be able to decrypt it at all if the service account password is, of course, significantly strong enough. That brings us to DC syncing. If you recall from my explanation in Active Directory, we typically want to have multiple domain controllers because we want to eliminate single point of failures. So we need a way for domain controllers to replicate changes with each other, which is the MSDR-SR protocol, which stands for Microsoft Directory Replication Service Remote Protocol. This protocol is granted to all domain controllers and domain admins by default, right? But could potentially be also granted to non-domain controllers or non-domain admins as well, because it literally is something that you can assign to users. If you compromise a user that has the replicate directory changes all permissions, that means that that user is capable of leveraging that remote protocol and therefore basically fooling a domain controller into replicating changes with you, which will include, surprise, surprise, password hashes for every user in the Active Directory environment, including that KRB TGT account that we talked about. There's a tool out there called Mimikatz, which allows us to perform DC syncing attacks by specifying the domain and the user that we want to actually compromise. So in this case, we compromised a user that had DC sync permissions on asgard.corp, and we specifically want to Kerberos asgard KRB TGT, because again, that KRB TGT account is the KDC's long-term key, which is signed, which is used to sign the pack for ticket granting tickets. So if we compromise this account, we can give anyone any permission in that Active Directory environment that we want. That brings us to our lab, Kerberoasting, lateral movement, and DC syncing. So I will be switching screens here again to my screen 1. There we go. Jump in my VM and into the lab guide right here. All right, so we have 2 agents basically running on our workstation. We will be interacting with one of them. The first thing that we actually want to do is we want to check whether or not there are any service accounts in Active Directory. Again, Kerberoasting basically means requesting service tickets, but in order for us to request service tickets, we need to make sure that there are actual service accounts. We can leverage a reconnaissance module in Empire called getUser, and we can actually toggle the SPN flag to true. Now, the SPN flag is the service principal name flag, which is a property that is only assigned to service accounts. So if an account has a SPN property set, that means that that particular account is a service account. So we will use the getUser command with SPN set to true. We will submit that to actually take a look whether or not we have a service account in the environment. Now, again, there is some jitter implemented in Empire, so it does take a little bit of time to get that information back, but eventually we do see that there is a service account called SVC underscore entry point, and it seems that that particular account is in fact going to be part of the domain admin group. That's quite interesting. If you're able to Kerberos this account and decrypt or brute force the password of this account, that means that we would now have domain admin privileges on this particular domain, allowing us to compromise said domain. So in order for us to do this, we can actually perform a Kerberoasting attack. We will be performing a Kerberoasting attack using a C# assembly task, which allows us to upload a file. Now, before we upload a file, we actually need to download the file that we have to need or that we have to use, which is called Rubius. Luckily for us, Malvin Langvik, a fellow security researcher, has a pre-compiled rubius.exe available for us. So if we would browse to the URL on our workbook, we would actually automatically download Rubius. Once we download Rubius, we can click on this upload button, click on this pay-per-click button to upload Rubius. Now, I don't have to do this because I've already uploaded Rubius before. We select Rubius from our drop-down list. And now that we have done that, we are going to execute a Kerberoast attack, specifically Kerberoasting SVC underscore entry point. And we also use this /no-wrap flag to basically allow us to easily copy paste the password hash that we are going to get back for brute force measures. So now we are performing this Kerberoasting attack in the environment. I'm going to minimize my screens for a bit. Here we go. Okay. And now we are going to create two new files. I already have them created, called hash.txt and password.txt. You can simply go back to your desktop, right-click, click Open in Terminal. You would have a desktop. You do gedit passwords, or password, in this case, .txt. That's going to open up a G editor. And we will have to copy the actual SVC entry point hash to the file. So we literally select the actual hash, we right-click, we select copy, we go into our gedit, we paste, we delete the white spaces, we save this file, which I already did. So once that is done, we also are going to create a new file called, sorry, I did passwords. That was not password, that was hash.txt. So sorry about that, hash.txt, there you go. And then we have passwords.txt, which is going to be our password file. And here we can basically just dump in some passwords like let me in 123, password, password 1, password 2, etc. You could also use a already pre-established word list for you. A very popular one is called RockU or WeakPass. That's perfectly fine as well, as long as change me 1234 exclamation mark is in there, because that's going to be the password that we gave to the service account for this particular workshop. So once we have these two files, we need to install hashcat. We can do that using sudo opt install hashcat-y, which is going to install hashcat for you. I already installed hashcat. If you want to use John the Ripper, which is another popular password cracking tool, you can do that as well. I've basically posted instructions of John the Ripper and how to install that in the electronic workbook as well. Once we have hashcat installed, we could use hashcat-m, which stands for mode. We are going to use mode 13100, which is the service ticket mode, to basically decrypt service tickets. We are going to reference the hash.txt file. We are going to specify -a0. A0 is the attack mode, and 0 means word list mode. So we are going to have to specify a word list, which in this case would be passwords.txt. We are going to run hashcat, and eventually hashcat is going to spit out a decrypted service ticket for us, which is going to showcase the actual password hash. Takes a little bit of time for Hashcat to initialize though. So it literally says, please be patient. So I will. And there we go. Eventually, Hashcat succeeds. And we see that we have successfully decrypted this service ticket. And the password is in fact change me 1234 exclamation mark. So that now means that we have the clear text password of a domain administrator. So what we could now do is we could go back into our interact window. We could now do PS remoting, which is a built-in lateral movement module in Empire. We could specify a computer name. In this case, that would be sandbox dc01.sandbox.pomezone.lab. We can specify the listener, and we can specify a username, which in this case would be sandbox svc entry point, and specify a password, which would be change me 1234 exclamation mark. We press that submit button, and eventually, if we go back to our task window, we are eventually going to get a new agent that is running on the domain controller. Now, it could take a little bit of time because, again, Empire does take a bit of time to execute their commands. As I have implemented some sleep time, you can see that we do get a new agent back. We see that we have this little agent or a person emoticon, which basically means we are running under an elevated process, meaning we are currently running under high integrity. Our payload is running as administrator, again, on the domain controller. So now that we are on the domain controller, we could be performing a DCSync attack. Again, Empire has built in DCSync modules, so we could perform DCSync, specifically DCSyncing sandbox KRB DGT, which stands for that KRB DGT account of the sandbox domain, which is once again going to be the KDC's long-term key that is used to sign the tag inside of a ticket granting ticket. So if we have the KRB DGT hash, we could essentially start forging our own ticket granting tickets, including a ticket granting ticket that will get us access to the parent domain as well. So I will submit that task, and this is going to take, again, a little bit of time. Mimikatz does take a little bit longer than all the other Empire tasks, so bear with me. But eventually, we are going to get the KRB DGT hash, and we need to actually take note of that AES-256 output because we will use it later on in the labs to, in fact, create a golden ticket and hop parent-child relationships. All right, so we do get that KRB DGT hash here. And you can see that we have that AES-256 HMAC. That is going to be the password value, the hash that we want to actually save, right? That is going to be very important as we will be using that particular password hash in a few minutes. All right, so that's pretty much it for this lab, right? Now we need to talk a little bit more about parent-child abuse and then tree root abuse as well. So I'll stop my share again, and I'll share my other screen once again. Here's screen 2. All right, so when we talk about Active Directory compromise, right, after we already compromised one domain, it becomes relatively straightforward to compromise domains that are trusted by the domain that we compromised. Now, there are two generic concepts that we could use. We have the child to parent hop, and we have the tree root generic hop. So one of these techniques only works between parents and child, and the other technique only, well, works basically for any relationship as long as it's a two-way trust. So let's start child trust first. In order for us to abuse parent-child trust, we need to know that there is a functionality in Kerberos called SID history. Now, SID history, or security identifying history, is originally invented by Microsoft to facilitate migration from one domain to another domain. So let's say again that we are Dracono.corp and we want to acquire Thunderbirds.corp, right? We could basically decide to migrate people from Thunderbird to Dracono. But that is going to basically be a process that is going to take a bit of time. Right? It kind of makes sense. We have thousands of employees. We can't just snap our fingers and migrate everybody over in a jiffy. Probably going to take several days, maybe even several weeks, where we sometimes will have issues where your old domain is still alive, your new domain is alive, and people might need access to resources in the old domain, although they already have a new account. So in order to facilitate this, Microsoft created SID history. This basically allows us to add secondary security identifying information to a user account. If a user then tries to access a resource, it's going to be checked not just by the main security identifier, but also by the history, right? So the secondary security identifier. So how does that work into our advantage? Well, if we already abused, if we already compromised the KRBTGT of a child domain, we basically have control of the KDC's long-term key, right? So we can start forging our own ticket granting tickets. Now, if we can forge our own ticket granting tickets, that means that we can start messing with the security identifying information. So we could literally create a ticket granting ticket that states that this user used to be a domain admin, well, actually an enterprise admin on the root domain. So now when we try to access a resource in the root domain, so in our case, in our lab environment, that would be bonezone.lab, well, now our ticket would be validated with our current permissions, but also with our security history, which we now forged to look like we are an enterprise admin. And of course, enterprise admins have domain admin rights on every domain inside of the same tree. That basically means that we would be allowed to access the root domain controller and compromise the root domain. Now, I mentioned golden tickets a few times, right? So what exactly is it? Well, again, if we compromise the KRBTGT account, that basically means that we could start forging anything inside of this privileged account or privileged attribute certificate. That means that we could start modifying the security identifier to point, once again, to the enterprise admin group on the root domain. So how do we execute this attack? Well, fairly straightforward. Both Mimikatz and Rubius have the capabilities of actually executing this attack. We could literally create a golden ticket to specify, again, the security identifying history of an enterprise admin on the root domain, allowing us to laterally move to the root domain and compromise the root domain as well. Now, Cobalt Strike as well as Empire have built-in golden ticket tasks. We are using Empire here in the lab environment. So it's pretty straightforward to create the golden ticket with extra SIDs. Or in my opinion, a better way of doing things is actually using Rubius, as Mimikatz is written in C++, or C even, while Rubius is written in C#, meaning it's a lot easier to execute in memory without leaving too many indicators of compromise with an asterisk, because of course, executing assemblies in memory is also not the most OPSEC safe thing, but it's definitely more OPSEC safe than running Mimikatz. So that's how we can hop parent-child trusts. We can also hop tree root trusts as well. And that has to do with the concept of delegation. Now, domain controllers are actually configured for unconstrained delegation. This is a required domain controller capability. Now, unconstrained delegation, well, it's unconstrained, so it should ring a bell. right? That means that it's probably not the most secure thing in the world. It would actually be quite right, because delegation, specifically unconstrained delegation, has a fun little drawback, which means that we could potentially harvest arbitrary ticket granting tickets. How does that work? Well, we need to understand what delegation is. In order for us to understand delegation, we need to know that there are three types of delegation. We have unconstrained delegation, constrained delegation, and resource-based constrained delegation. Now, in the SAC 565 course, we cover all of them. In this particular workshop/lab environment, we're only covering unconstrained delegation. So what is so special about unconstrained delegation? Well, if a service is configured for unconstrained delegation, that means that a service ticket is not just going to include a privileged account certificate, but it's also going to include the entire ticket granting ticket of a user. Yes, you heard that correctly. The entire DGT is in fact shoved into a service ticket, much like a Thanksgiving turkey, right? So how does that work? Why is that relevant? Why was this ever invented? Well, let's assume the following scenario. Let's say that we have a user that is going to authenticate to a web server. And that web server needs to fetch information from a database. Well, in order for this to work, again, this user would have to first create a ticket granting ticket and then use the ticket granting ticket to request a service ticket to access the web server. But now we have a little bit of a problem because the web server now needs to retrieve records from a database server on behalf of the user. But that's the problem because the user is the user and the web server is the web server. So if the web server would simply authenticate to the database server, the web server would get access on behalf of the web server. So probably getting access to all of the data, not just the data that this particular user needs or is even allowed to see. So we need a system that this user, or that this web server rather, can impersonate this user. And that is done through delegation. So with unconstrained delegation, what actually happens is we have that pre-authentication. So our user sends an encrypted timestamp to the domain controller. The user gets the ticket granting ticket back. Once the user has a ticket granting ticket, they request a service ticket for a system that is configured for unconstrained delegation. So the domain controller is going to say, wait. This system is configured for unconstrained delegation. I will give you a special service ticket, which will include your ticket granting ticket. Now, this user is using that special service ticket to authenticate to the service. And this new service now needs to use their, guess what, target long-term key to decrypt the pack. But now there is no pack. There is, in fact, the the client's ticket granting ticket. So what the server now can do is it can extract the ticket granting ticket and it can use the user's ticket granting ticket to request a new service ticket on behalf of this user to authenticate to the SQL server. Now, this is, of course, pretty straightforward, but it's unconstrained delegation because guess what? This web server now has the entire service ticket. So the web server could technically go to any particular resource in the domain on behalf of the user, not just service B, because the user can now be completely impersonated by the web server, as the web server is in possession of the passport, right? The ticket granting ticket of the user that authenticated to the resource. It gets worse though. So how do we recognize unconstrained delegation? Pretty straightforward. We have some enumeration tools that can give us that information. But as I said, it gets worse because what if we can somehow force a high value target, right, an HVT, to authenticate back to us? Well, it turns out we can actually do that. We can do that through the print spooler service. And the print spooler service is a service that is enabled by default on every single computer and server in the environment. Now, if you send a specifically crafted RPC call to that service is going to try to connect to you. Now, services in a Windows environment are running as system. That means that the computer account is going to try and authenticate to us. So if we somehow compromise a system that is configured for unconstrained delegation, we can then try to coerce authentication from a foreign resource, for example, a domain controller. The domain controller is going to authenticate back to us, which now means we can steal the domain controller's ticket granting tickets and impersonate that domain controller to compromise the foreign domain. And what gets worse is Microsoft claims that this is a won't fix issue. So Microsoft is never going to fix this. This is intended functionality based on the printer protocol. So as long as you have the print service running on the tier 0 asset, so the domain controller, anybody in the domain would be able to force authentication from the domain controller to any arbitrary resource in the domain as well. And it's not just the printer, it's also file encryption. So in 2021, a French security researcher actually found a secondary way to also coerce authentication using a tool called Petit Potam, which is French for little hippo, quite funny. But that's basically a tool that is basically going to also perform coerced authentication using file encryption remote procedure calls. So the attack flow is relatively straightforward. The first thing that we have to do is not straightforward. We have to compromise a system which is configured for unconstrained delegation. But in our case, we actually did it, right? Because again, we now have control of the KRBTGT, so we could now laterally move to the domain controller, which is configured for unconstrained delegation. Once we are on a system that is configured for unconstrained delegation, we force authentication, we harvest the ticket granting ticket, and then we impersonate the foreign principal to compromise the foreign domain as well. There are two tools that we need for this. We need Rubius to monitor for incoming ticket granting tickets, and we need a tool that allows us to perform the RPC call, which is called invoke spool sample. Now, unfortunately, on a command and control channel like Empire, at least the Empire version used in the lab, we can't actually perform this attack with just one agent. We need two agents. One agent is going to be sacrificed for Rubius in monitoring mode, and the second agent will be used to coerce authentication to our unconstrained delegated system. This is because Empire is not backgrounding .NET assemblies, at least not the version that we are using, but I've heard from the developers that in a next iteration of Empire that is going to be fixed, so we will actually be able to execute Rubius, for example, in the background. But for now, we need to spawn two agents, one that is going to monitor, the second one to actually perform the coercion attack. Which brings us to our final lab of the day, hopping trusts. Right? So again, I'll be switching screens here to screen 1 in my virtual machine. There we go. Right, and I need the lab guide on my secondary screen. Go. So first things first, we are going to be interacting with the domain controller agent, right? So if you go to your agents, we are going to be interacting with the domain controller agent. And the first thing that we are going to have to do is we will have to enumerate trusts because we will need the security identifying information of the foreign domain, which in this case would be bone zone. We set the API to true, and that's basically it. We submit the task and we wait until we get outputs. All right, now we get outputs. We need the target bone zone and we need the target security identifier. So I will create a node here to gedit op nodes. So sit of bone zone dot lab. Sit of bone zone dot lab is going to be this right here. Copy, paste, and AS256 hash of KRB TGT. Need to go back to our previous task output for that one. Copy, paste. All right. So now that we have that information, we can create a golden ticket. And we can create a golden ticket using Rubius. Sorry, assembly. There we go. So we specify C# assembly. We select Rubius from our drop-down list. And now our parameters are going to be golden, AS256, which will be the AS256 hash of our KRB TGT account. So I will replace that with the actual value that we enumerated. So this value. User is going to be administrator. So I'm going to be impersonating the administrator account. Domain is going to be our current domain. So in this case, sandbox.bonezone.lab. And we are going to add extra security identifying information, which is going to be the security identifying information of bonezone.lab-519. And -519 is the identifier for enterprise admins. We also specify new pack because there was a patch that basically broke this particular attack, but then the offensive security community found a bypass. So we specify new pack to use that particular bypass. So now that we have that command established, we are going to execute the command. Oh, did I add pass the ticket? Yes, I did. /ptt stands for pass the ticket. And now we should see that eventually we get a base64 encoded ticket, and we see that the ticket was actually successfully imported. So that now means we created a golden ticket with enterprise admin rights. So now that we have that, we should be able to, once again, laterally move. And this time, we are going to laterally move to bone zone, dc01.bonezone.lab. We specify our listener. We don't have to fill out a username or a password because we will be using the ticket granting ticket that we just had created. And now if we wait again for a few moments, we will see that eventually we'll get an agent back on our parent domain. So there you go, bonezone.dc01, which now means that we could be performing a DCSync attack on bonezone as well, this time specifying bonezone KRB TGT, which gives us the KRB TGT hash or the KDC's long-term key of bonezone, allowing us to once again create a golden ticket that gives us full admin rights to any particular resource on the bonezone domain. Now we actually are going to be performing the lateral movement twice. So if we go back to our sandbox DC01, we're going to do PS remoting once more to bonezone DC01, bonezone.lab, because we need two agents to basically get the TGT hash of Treasure Island, which is our third domain in the environment. And I realize I'm a little bit over. I apologize for that, but we are almost at the finish line. So I have two domain controller agents here. I'm going to open both of them because I will need. On one of them, I will be executing my assembly. which is going to be Rubius. And I'm going to be executing Rubius in monitoring mode, specifically targeting treasure DC01. And I'm going to run it for 2 minutes or 120 seconds. So that's basically it. I also need to make sure that I have my invoke spool sample ready, because I basically will have 2 minutes to switch agents and to execute that as well. So I will call this tickets to, well, no, because this is a new range. This is fine. Ticket.txt. Okay, looks good to me. So submit that. Switch agents, right? Very important that you switch agents. And here we are going to invoke scripts. And the script command is going to be invoke spool sample. Invoke spool sample to the remote domain controller. Where's my invoke spool sample command? So I didn't put it in there yet, so I'll do it manually. Invoke spool sample commands treasure dc01.treasure islands.lab bone zone dc01.bonezone.lab. Then my script path will be home Jenkins. What is it? Home Jenkins documents. Invoke spool sample.ps1. All right, so that is going to be executing as well. And now that that's executed, I'm going to start my file browser. I will go to C users public, which will have the file, which will contain the TGT of the Treasure Island domain controller. And then finally, right, the final challenge, which is not in the lab guides, right? The final challenge is to get a implant running on the Treasure Island domain controller, right? We cover it in the course, but of course, this is a learning journey, right? So you can figure it out by yourself if you want to. I'll give you a hint. You very likely will need another DCSync and another golden ticket. That's basically all that I'm going to say about that. Receive an error response. Well, that kind of makes sense because my 2 minutes were probably not finished yet. I'm going to try that again. As long as the 2 minutes aren't done, you basically will get errors because the file will still be locked by Rubius. But now I see that the 2 minutes are over. So if I would now go to basically the location in my console. All right, CD. There we go. We will see that we will have captured a ticket granting ticket for treasure DC01, right? So we could now import that ticket and do something with it, right? That's up for you to discover on your own time if you want. So yeah, that was, I know I'm over by 10 minutes, I apologize, but that was speedrunning Active Directory and Kerberos. So I hope you enjoyed. I hope you learned something. And the range is going to be there to stay, right? So you can spin it up whenever you want, tear it down whenever you want. The only thing is, of course, hosting costs. If you only leave it up for a few hours, maybe like $1, maybe $2, probably nothing more than that. But yeah, that's pretty much it for me. So I hope you enjoyed, and I hope to see some of you in a Stack 565 class, or maybe even 699. Thank you for attending the workshop. And yeah, if you have any questions, feel free to reach out. The PowerPoint is in the repository as well. My contact details are on there on Twitter, or if you want to add me on LinkedIn, that's fine too if you have any questions. I'll also be taking a look at Discord as well as the QA buttons there, and I'll answer the questions on Discord because I want to, of course, be respectful for everybody's time. So thank you again for joining. I hope to see you in another workshop or maybe in one of my classes.